Hi, everybody. Day three, or movie three, if you will, of our final review, venturing into chapter 12. Um, and then we're going to have to take at least a couple of days on this. I think I plan on two, just to get the pertinent information, summarized here. Okay, so let's go fast. So, what we really primarily focused on was graphing quadratics in the three different forms. And I have an example of each form right below. These examples I got from Ms. Ling. Shout out to her. And she used on a worksheet, and it was really great what happens with these three. So anyway, we'll get that later. Let's focus on each one then. This first one is called standard form. All right, and then this is what you need to know, the pertinent information of this. And we're going to summarize and actually just get the most important details. So this is standard form. Standard. Squeeze that in here because I don't want to waste space on my work here. And then what pertinent information sticks out when you're in standard form? Well, it's actually, there's two things you should primarily know about this. Then we're actually going to graph one and add to it. But the first thing is, if I plugged in 0 for x, these would go away and you'd have C for Y. So what sticks out like a sore thumb is 0 comma C is the y-intercept. So this is something you can find instantaneously when something is in standard form. All right, and then the other thing you have to know is that magic formula, which now you could see parts of it are a little bit familiar. And I had some people do that in my class. They recognize this as part of the quadratic formula. All right, but it really it does have a relationship, but you see those parts in it. But anyway, blabbering again. Negative b over 2a gives you the x coordinate of the vertex, and then this fancy notation just means you take this number that you found and you plug it in for x to find the y coordinate of the vertex. That's just function notation. So if we take this real simple example, negative 2x minus, whatever, you see it. The y-intercept staring you in the face. It's 0, 0, cancels these out, comma 30. So that's the y-intercept. You can find that in a millisecond when you're in this form. All right, and then just to get the vertex, you would do negative b over 2a. And then this gets the ball rolling for what happens in this quadratic. All right, so you got negative 1 as the x-coordinate. What is the y-coordinate? Well, what is the y-coordinate when you given any x-coordinate? You have to plug it in. Now, had a little rough time plugging in and evaluating, and then that caused a lot of issues. So be very careful that you do exponents first. This is 1. 1 times negative 2 is negative 2. No, you don't distribute and then square. That's a violation of PEMDAS. All right. And then 34 minus 2 is 32. And then you can go on and graph, but really this is how you get the ball rolling. Vertex, and then this is the y-intercept. All right, and then I'll do an example where you can find more stuff, but that's at least what you get out of standard form. Not to bore you, but in relation to chapter 14 and 15, which is the quadratic formula that I did mention before, I did want to do this. If I plugged in 0 for y and then solve for x, that would give me the x-intercepts. When you're in standard form, the only way that you could solve this was all about chapter 13 and then maybe 14 and maybe a little bit of 15. If it is factorable, we could solve this by factoring. If it is not factorable, then that's when the quadratic formula comes in. Now, I'm going to bore you with the details, but what happens if I use the quadratic formula and I get I numbers? Okay, paused for a reason. If I get I numbers when I solve for this equation, that means there would be no x-intercepts. That was what the discriminant was all about and all that other stuff, but blah, 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 blah. I don't know if I'm going to get into that with the graphing. Those with a graphing calculator, you have a little bit of an advantage, and you can find that through finding the intercepts. Okay, so let's move on. This form, this is called intercept form or factored form. Intercept or factored form. All right, and the reason it's called intercept form is because the x-intercepts are staring you in the face. See, when I do plug in 0 for x, wrong, 0 for y, my bad dogs, then when you solve, this a becomes irrelevant. I'm sorry, I just crossed off the wrong thing. And then when you use the zero product property, you get x equals z1 and x equals z2. So when I plugged in 0 for y, I get z1 for x and z2 for x. Basically, the x-intercepts are staring you in the face. All right, now, I don't want to do this as a formula, but I guess I will write it down. Where is the vertex compared to these two x-intercepts? Well, in a quadratic, if I have an x-intercept here and an x-intercept here, then the x-coordinate of the vertex is right in between. So that would be the x-coordinate of the vertex. So that's how you find it. All right, the formula for it is z1 plus z2 divided by 2. That's the average of those zeros, comma, plug that number in to get y. All right, and then it's more useful to actually go through a question that has numbers. For instance, this is in intercept form. This -2 is irrelevant. So the x-intercepts are 3, 0 and -5, 0. All right, and again, you just have to have real basics for solving to understand that. Zero product property, divide both sides by -2, and then use the zero product property, set each parenthesis equal to 0. So I'm showing the work backwards. That's how I get these. Plugged in 0 for y, I got 3, and -5 for x. So, as I told my students, don't formula it out. Just make a quick sketch. Here's -5, 0. Here's 3, 0. The x-coordinate of the vertex is right in between, which is -1. So the vertex is -1, comma, what? Well, to find any corresponding y value, you plug in x. All right, so this is -4, and then this is 4. 4 times -4 is -16. -16 times -2 is 32. Wait a minute. That's the same vertex as I got over here. That's why Ms. Lang did what she did. All right, but anyway, you can go on and find other coordinates to get the graph. These are the pieces of information you get when you're in intercept form right off the bat. Then you have to really separate these two. These look different. This is parenthesis times parenthesis. This is a times x minus h squared, parenthesis done, plus k. This is called vertex form. The vertex is staring you at the face. It's taunting you. All right? And then that's really the main thing that you see in this one. Okay, so let's look at this one. So this is in vertex form. By the way, and we made a big deal about this, and I did say this, the x-coordinate of the vertex turns the set of parentheses into 0. Or else we play the opposite game. Whatever you need to do, what turns this into 0 when I plug in what for x? And the answer is -1. Or x plus 1, the opposite of plus is minus. I don't know. Whatever you got to do to get it memorized, this is what happens. And then when I plug in -1, -1 plus 1, 0. 0 squared is 0. 0 times -2 is 0. 0 plus 32 is 32. Wait a minute. That's the same vertex as the last two. All right, well, let me just finish this off here. Well, I guess I am done, because that's really what you get and know from vertex form, the vertex right off the bat. So, I will do this, though, just for giggles, because this is something that we did do and solve back in the day. I'm going to go ahead and find the x-intercepts through a way that kind of baffled some of my students when we're in, this form of a quadratic. Solving when we have a binomial squared there. And what we talked about was we were able to solve this by isolating the square. So what am I doing? I'm finding the x-intercepts through a method of solving that we did at the end of chapter 13, I believe. All right, so you plug in 0 for y, and then let's solve for x. Well, the first thing you were supposed to do is subtract 32. So again, I'm kind of leaking into later chapters and relating it to what it means in graphing. And it's not going to hurt you. You don't have to necessarily do this for the final, but it's good math to practice. And then you square root both sides, which is freedom. X plus 1 is free. And then this is plus minus 4. And then the reason I did this is to show the genius of Lang when she made this worksheet. 4 minus 1 is 3, comma 0. Negative 4 minus 1, negative 5, comma 0. So the genius of Lang was she made this worksheet that I did share with my class that we had a quadratic in standard, we had a quadratic in intercept form, and we had a quadratic in vertex form. And they all were the exact same graph. And that's the point. These can be in different forms, but, the same attributes. Doesn't always have to happen, of course, but we're just making a point here. All right, so anyway, the key things to summarize, because it kind of went a little far on some of this other stuff. Standard form, y-intercept staring you in the face, that's how you find a vertex. Intercept form, x-intercepts are staring you in the face. Get them? And then the vertex's x-coordinate is right in between, and then you proceed from there. Vertex form, vertex is staring you in the face. All right, and that's basically it, and you go from there.